Dear student, in previous lecture, I have already discussed what is Faraday's law, then Faraday's law in differential forms, Faraday's law in integral form. Faraday's law in integral form is nothing but the close integration of line integral means E bar dot dl bar is equal to surface integration of minus del b by del t ds bar. This is nothing but the Faraday's law in integral form. Then again I already discussed the Faraday's law in differential form. In differential form equation is curl of E bar. Curl of E bar is equal to minus del b bar by del t. This is forms of differential forms of Faraday's law. Now in today's lecture, discuss the displacement current. What is meant by displacement current? And what is the relations between the current and displacement current? Now today discuss. Before discussing the displacement current, first of all consider the two plates. And these two plates, suppose first plate is positive and second plate is negative, and these two plates separated by distance d, Now if you apply the potential between these two plates, so and these two plates fill with air media. Again, if you fill the any materials, if you fill this air media, now if you apply the potential between these two plates, it means that the electric field is produced, and direction of the electric field is always from positive plate towards the negative plate. Positive to negative. Directions of the electric field is positive to negative. Means now discuss the what is meant by displacement current. The changing electric field in a vacuum or in a media between the condensed plate, means this these two plates used as a condenser. This condensed plate is equivalent to the current. This current flow as long as electric field is changing, this current is known as displacement current. The displacement current is due to the change in electric field. It is denoted by ID. Means ID current is nothing but the displacement current, and this displacement current is the current between these two plates, positive and negative. And this displacement current ID is equal to epsilon 0 del phi by del t. What is meant by phi? Phi is nothing but a flux, electric flux, and electric flux is equal to the surface integration of E bar ds bar. Surface integration is E bar ds bar. Means phi is the total electric flux through the surface. Yes. The displacement current is not involved in actual transfer of charge. The idea of displacement current allowed to retain the continuity of current through the capacitor. However, displacement current is not a transfer of charge. Displacement current is, note down, displacement current is not a transfer of charge. Now then discuss the what is explanation from the displacement current. Displacement, now show the displacement current is equal to current. I mean the displacement current due to the change in electric flux. Okay. Now consider the two plates. First plate is positive and second plate is negative, as shown in figure. An electric field is produced, and electric field, direction of the electric field from positive plate to negative plate. The real current I, the charging of the plate of condenser, due to which the electric field E between the plate changes. We already discussed when if you apply the potential between these two plates, the electric field is produced, and direction of the electric field from positive to negative. It means the frictional displacement current ID between the plate is related with changing electric field. But real current and displacement current, it depends now in the real current the displacement. Now let us Q is the charge on a plate at any time. E is the magnitude of electric field due to the charge Q, and A is the area of condensed plate. Means that they can separate A is the area of the condensed plate. The Q is equal to, means charge Q is equal to epsilon 0 area of condensed plate and electric field, means Q is equal to epsilon 0 AE. Differentiate this equation with respect to time, then we can get the real current, means I is equal to dq by dt, and the rate of change of charge is equal to current, means I is equal to dq by dt is equal to epsilon 0 A del E by del T. And this is called as the equation number 1. Suppose consider the equation number 1. The value of displacement current between the plate of condenser is given by ID is equal to, condenser of the given by is equal to epsilon 0. Displacement current is nothing but the rate of change of electric flux. Rate of change of electric flux means ID is equal to epsilon 0 del phi by del T. Phi is nothing but the electric flux, and electric flux is calculated electric field and area, means epsilon 0 del EE by dt, means ID is equal to epsilon 0 A dE by dt, and this is the equation number 2. From equation 1 and 2 it is clear that right sides are equals, means epsilon 0 A del E by del T in right side of the equation number 1 as well as equation number 2. From equation 1 and 2 means right hand side are equals, means left hand side also equals, I is equal to ID. Thus the displacement current ID can be considered as a frictional current to simplify the continuous real current from one plate across the capacitor gap to the other plate. No charge move across the gap between the plate. So the displacement current is not a transfer of charge. Displacement current is not a transfer of charge. The medium between the plate is subjected to stress and strain due to the change in electric field between the plate. The resulting productions of displacement current. According to the Maxwell, all electric current are divergenceless. That is, electric current must be closed according to him. During the charging or discharging of the capacitor, the real current is closed by the displacement current which is flowing across the two plates of capacitor. It means that the all electric current are the divergenceless. That is means the electric current must be closed. According to Maxwell, charging and discharging of capacitor, the real current is closed by the displacement current. Real current closed by the displacement current which is flowing across the two plate of the capacitor. Okay, the next point discussed here. Maxwell electromagnetic equations. In your syllabus there are 4 types of Maxwell equations are studied. First equation, second equation, third equation and fourth equation. First equation based on Gauss's law of electrostatics. First equation depends on or based on Gauss's law of electrostatics. Second equation based on Gauss's law of magnetostatics. Third equation based on Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. Fourth equation based on Ampere's circuital law. And all the law, Gauss's law of electrostatics or Gauss's law of magnetostatics, Faraday's law in electromagnetic inductions, and Ampere's critical law. Already basic knowledge, you already know that. Now according to the Faraday's law, the change in magnetic field produces the electric field. Maxwell modified the Ampere's law. According to the Maxwell, the change in electric field in a space produces magnetic field. It means either electric field or magnetic field changes with time, the other field is induced in the space. Means electric field or magnetic field changing with time, the other fields is induced in the space. This analogy tells us the generation of electromagnetic disturbance of time varying electric and magnetic field. This electromagnetic disturbance propagating through the space is called as electromagnetic waves. Maxwell predictions that when the moving electric charge is oscillating, it should be an electromagnetic waves consisting varying the electric field and varying magnetic field perpendicular to each other to the direction of propagation of waves. The Maxwell gives 4 differential equations. First differential equations on the basis of Gauss's law of electrostatics, means differential form is equal to del dot d bar is equal to rho. First Maxwell equation in differential form, del d dot d bar is equal to rho, and the integral form closed surface integration of d bar ds is equal to the volume integration of rho. Means closed surface integration d bar dot ds bar is equal to the volume integral rho dv. Then second equation, based on Gaussian electrostatics. Line integration means closed line integrations means closed integration of E bar dot dl bar is equal to the minus del dot b dot product of magnetic field, means del dot b bar is equal to 0, and then the integral form closed integration of b bar dot ds bar is equal to 0, means closed surface integration of magnetic inductions, means b bar is equal magnetic field is equal to 0. Third equations depends on the Faraday's law, the integration form curl of electric field is equal to the minus del B bar by del T. Means rate of change of magnetic flux. Magnetic field means curl of electric field is equal to minus rate of change of magnetic field means del B minus del B by del T. And this equation forms in integral form is closed integration of line integral E bar the dl bar is equal to minus surface integration of del B by del T ds bar. And fourth equation, Maxwell's fourth equations is depends on or based on Ampere's circuital law. Means Ampere's circuital law means it means that curl of magnetic induction means del cross B bar is equal to mu naught J bar plus mu naught epsilon naught del E by del T. Now the integration forms is closed integration of B bar means line integration B bar the dl bar is equal to mu naught surface integration of J plus del T by del D by del T ds bar. Now friends, in next lecture we already in next lecture discuss here the one by one equations. Maxwell first equation, Maxwell second equations, Maxwell third equations, and Maxwell fourth equations. Then the Maxwell equations as well as discuss the in next lecture physical significance of each equations. Physical significance of each equations. Okay, now I'm stop here.